Today I am going to discuss about the clover leaf model. Clover, it is a model that is named as a clover leaf model, and it is about the tRNA. Basically, this model is proposed by Holly in 1965. Basically, if we talk about tRNA, tRNA is consist of 70 to 90 nucleotides. 70 to 90 nucleotides, and it is present 10 to 20% in cytoplasm. That are it is the amounts that are important for the MCQs as well. tRNA is basically consists of 70 to 90 nucleotides, and it is present 10 to 20% in cytoplasm. In all the types of RNA, there are different types of RNA like messenger RNA, tRNA, and rRNA. They all are the types of RNA, but the smallest type of the RNA is tRNA, and it is a single-stranded RNA. It is a single-stranded RNA, but in some cases it is also a double-stranded RNA, but normally it is single-stranded RNA. And if we talk about its molecular weight, that what is the molecular weight of tRNA? The molecular weight is 25,000 AMU, and it has anticodons as well. And it is a three-dimensional. What does mean by three-dimensional? Means it has three axes: x-axis, y-axis, and z-axis. We'll be discussing that how it has x-axis, x positive as well as negative, y positive as well as negative. So the means tRNA is basically three-dimensional as well. And if we talk about the total amount of tRNA that is present, it is 60. It is 60, the total amount of tRNA. But if we talk about humans, so humans have 45 tRNA, the amount of tRNA. 45 is the amount of tRNA, but in humans, and 60 is all over. If they ask about the human, so you have to go 45, but if it is normally it is asked, so you should go with the 60 amount of tRNA. Now, what are the postulates? Postulate according to this model. According to this model, the clover leaf model, tRNA basically have 5 arms and has 4 loops. We'll be discussing that how it has 5 arms and 4 loops. So these are the 5 arms. It has 4 loops. This is the structure of tRNA. This is the first arm. This is the second arm. That is the third arm. That is the fourth arm. And that variable loop, it can be 4 as well, and it can be 5. Like it is 4. This one is also count as a arm. It has 5 arms but has a 4 loops. It has 4 loops. How? This one, the acceptor arm, has do not have a loop, but remaining all have a loop. It has a loop. It has a loop. It also have a loop, and it also have a loop. But the acceptor arm did not have a loop. Means it has a 4 loop but having a 5 arms. That is because the acceptor arm do not have a loop. Only these 4, the T loop, variable loop, anticodon, and D loop has the loops, but it does not have a loop. Now we are going to the first loop. That what is the first loop? That is as I said, that is an acceptor loop. It does not have a loop, so it is acceptor arm. Basically, it receives or it carries the information receives the information from the messenger RNA, and then it carries that information to the anticodon arm. We'll be discussing that how. So acceptor arm basically receive information from the messenger RNA, and it is consist of, basically if we talk about the arms, in arms there will be a nitrogenous bases, and if we talk about loop, that loop is consist of basically nucleotides. So here the loop is not present, only the arm is present. So there will be 7 pairs of nitrogenous bases. 7 pairs of nitrogenous bases out of, like if we talk about single, so there will be 4 single nitrogenous bases, but if we talk about the pairs, so it will be 7 pairs. And as I said that it does not have a loop. It does not have a loop, but it has an arm, and it is consists of 7 pairs of nitrogenous bases, and it receives information from the messenger RNA. Now this was the first arm. Now we'll be going through this arm, that is the second arm, that is a D arm, or we can say D loop as well. So D arm, the second, that is D arm, and it is a second loop, first loop, because that one do not have a loop. It is a first loop, and it has a D arm. D basically means dihydrouridine. What does it mean by dihydrouridine? Dihydrouridine means the one uracil and 2 hydrogen are attached with the ribose sugar. Means with the ribose sugar, one uracil is attached, 2 hydrogen are attached. So that is known as dihydrouridine, and as it has arm as well as a loop. Loop is basically consists of 8 to 12 nucleotides. If you talk about the loop, so a loop is basically consists of 8 to 12 nucleotide, and as I said that it has 1 uracil, that is nitrogen base in the arm, and 2 hydrogen in the that is attached with the ribose sugar. That is why it is known as dihydrouridine. Now the third one, that is anticodon arm. Anticodon arm, that is have a second loop, that is known as anticodon arm. If we talk about arm, it is consist of or made up of the 5 nitrogenous bases pairs, and single it has 10, but in pair it has 5 nitrogenous bases, and in loop there will be 7 nucleotides. And how many are anticodons in that nucleotide? From these 7, 3 will work as anticodon. 3 will work as anticodon. Then we are having the fourth one arm, that is a variable arm. That is the small arm, but it is also count as an arm and have a loop also, that is the loop 3. And it does not have a nitrogenous basis. It does not have a nitrogenous basis in arms, but it has more nucleotides, like it is consist of 4 to 21 nucleotides, more than all the nucleotides. This loop consists of 4 to 12 nucleotides, but it does not contain nitrogenous base. Then if we talk about the fifth one, that is a T loop, that is on the positive x-axis. As I said that it can be like, it is having that is positive x-axis, positive y-axis, negative x-axis, negative y-axis. To learn these arms, we can to learn these arms, we can give the names to them, like positive x-axis, positive y-axis, negative x-axis, negative y-axis. But this is a T loop, that is the last loop, that is the fifth loop, and it has a fourth one loop, or we can say T arm as well. So basically if we talk about the arm, it has 5 bases in arm, 5 bases in arm, and if we talk about loop, it has a 7 nucleotides in the loop. And it is also, T loop is basically also indicate as this one sign. So basically the T loop is also indicated by this sign. That is the sign for the T loop. Now if we talk about the function of the tRNA, that is a transfer RNA, the first function would be that it the transport of amino acid present in the cytoplasm to the site of the protein synthesis. Protein synthesis, that is a ribosome. So basically the work of the tRNA is that it will carry amino acid that is present in the cytoplasm. It will carry amino acid that is present in the cytoplasm. It will carry, and then it will take this amino acid to the protein synthesis, that is ribosome, that will make its protein then. So basically it has one work, that it will be transfer that amino acid from the cytoplasm to the ribosome. And second, the tRNA is basically coded for the specific amino acid. Like it is coded for the specific amino acid by the 3 nitrogenous bases. Each codon will be having 3 nitrogenous bases. So basically tRNA will be coded as a specific amino acid by the 3 nitrogenous bases. Now we are having 20 amino acids. Total we are having 20 amino acids. So 20 tRNA will carry the 20 amino acids. As I said that normally there are 60 amount of tRNA, but there are 20 types of tRNA. If they ask about the types, so there are 20 types of tRNA, but if the total amount, they are asking about total amount, so there will be a 60, that is the total amount of tRNA.